Hey, y'all. I'm here in our classroom to give you the next lesson. It's on ordered pair relationships. You're going to figure out two things today. You're going to understand how the signs will tell you which quadrant you're in, and we're going to also talk about reflections on the X and Y axis. We're going to be doing a lot of dancing today. So here's what you need to know. We have our coordinate grid, and yes, we now know how to plot ordered pairs. Now what you're going to learn is the name of the different quadrants. These are all called quadrants. Quad literally means four in whatever Latin or Greek language that is. So that's why they are called quadrants. We start with quadrant one. I like to think that quadrant one is called quadrant one because that's kind of the first one you learn, right? Last year you went positive, positive, and you stayed in this quadrant. So that's called quadrant one. Quadrant two is the next one over. This is called quadrant two because it is, I don't know why it's called quadrant two, but it's the quadrant where you have a negative number and then a positive number. So quadrant two is negative, positive. It's there on the top. Coming back down, we have quadrant three. Quadrant three is all the negative, negative numbers. When you have a negative, negative, you're in that bottom left area. And then swinging around to the last one is quadrant four. Quadrant four are the positive, negative numbers. So those are the quadrants. You got to kind of just memorize them. If you notice, they kind of go in a loop, a counterclockwise loop, starting with 1, 2, 3, 4, and do whatever you need to do to memorize those so that you can do really well on today's lesson. So if you understand what the signs are, you will know what quadrant it is without even having to graph it. You'll be like, oh, well, that's in quadrant one or quadrant three. Okay, let me show you what I mean by that. Which quadrant is -1, -8, -9? Well, -8 is negative, so we would go this direction. And then -9 is negative as well, so we would go down, meaning we would be in quadrant 3. Okay, remember I talked about how all of the negative numbers are going to find themselves in quadrant 3, and that proved true with this negative, negative. Which quadrant is 12, 1? So where would two positives be? Well, positives to the right, and a positive y is up. So we would find ourselves in quadrant 1. Okay, and have you noticed I'm doing Roman numerals? That's how we do quadrants. All right, which quadrant is -3 and then -1? Well, we'd go negative first, and then we catch the elevator up, and we would end up in quadrant 2. Are you guys starting at the swing of this? Okay, and I didn't even have to do that. I could have been like, okay, if we're going negative and then positive, that's going to put me in quadrant 2 because it goes 1, 2, 3, 4. All right. What if you don't even know the numbers? What if you just know that an ordered pair has a negative x coordinate, so this number is negative, and a positive y coordinate? Where would that put you? Well, if we make our little makeshift coordinate grid here, we would know that we would need to go negative for the x coordinate and positive for the y coordinate. We would be in quadrant 2, wouldn't we? What if it was positive x and a negative y? So that would be a positive x and a negative y. Where would that put me? Well, positive would be to the right. Negative would be down, so I'd be in quadrant 4. Speaking of Roman numerals again, this is 1, because there's one line, right? This is 2, because there's 2 lines. This is 3, because there's 3 lines. Where did they get 4? Well, in Roman numerals, this V equals 5. So if you have 1 before the 5, that equals 4, doesn't it? Fun fact for the day. All right, what if you have a negative and a negative? Where would that end up? Well, negative is to the left for the x, and negative would be down for the y. You'd be in this quadrant right here, quadrant 3. Kind of cool, huh? All right, so that was the first objective of the day. Now you know about the quadrants: 1, 2, 3, 4, positive, positive, negative, positive, negative, negative, positive, negative. Now we're going to talk about reflections. We're going to look at two ordered pairs that are only slightly different, and they're actually like mirror images of each other, either across the y-axis or across the x-axis. And we will go over that right now. So let's start with an example right here. We have -3, 2, and 2, -3. What is the difference here? Well, if we look, they both went up the elevator 2, right? So the y coordinate stayed the same. The really only difference is one went left 3 and one went right 3 from the origin. So they're actually called reflections. Because if we folded this right here on the y-axis and we folded it in, they would end up touching each other. Let me see if I can model this with this. So here I have an XY chart right here. If I have my -3, 2 and my 3, 2 here, and I were to fold along this XY, I say X earlier, this is the y-axis. If I were to fold it on the y-axis, they would be right on top of each other. That is what I mean by a reflection. If we fold across the y-axis, they touch, and they will be then exactly the same. So let me talk about, that's called a line of symmetry. This is all math words, but we're talking about line of symmetry today. And line of symmetry, the lines we're going to use today was we're going to use the y-axis for a line of symmetry, or we're going to use the x-axis for a line of symmetry. Let me explain what I'm talking about. If you give the reflection of the point -7, -7, let's model that. -7, -7 would be 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3, 4, 5, 6, 7. I would be right here, correct? Okay, so how come you don't erase now that I'm trying to erase you, lame? -7, 7 is right there. Now this says we're going to reflect it across the y-axis. That was the given axis they gave us. So what I want us to imagine is that fold on the paper, that line of symmetry is the y-axis. So we are down here in quadrant 3. If we were to fold along this, where would that point end up? It would end up, boom, right here, wouldn't it? This is quadrant 4. And we know that quadrant 4 is a positive and then a negative ordered pair, correct? So we would be at the exact same place just across the axis. So we would be at +7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, -7. And you can see that those are, oh, where did it go? Those are exactly the same distance from 0 from the y-axis. So when they flip and fold, they're going to be at the exact same point. So we're going to say that it is now at 7, -7. It went +7 this time instead of -7, but they both took the elevator down 7. As we're talking about this, I want you to see if you can find any connections and any rules or revelations, okay? So what if we have -5, 18? -5, 18, I'm not going to count, I'm just going to be like, okay, it's in this quadrant, right? -5, 18 will be somewhere in quadrant 3, right? Now we're going to flip it, reflect it across the x-axis, and that's the horizontal one. So let's think about this. I'm in quadrant 3. If I were to reflect it across the x-axis, this time I'm going down, aren't I? It's going to flip me down into what quadrant? Well, now I'm down here in quadrant 3, the negative quadrant. I'll be flipped, and I will end up right here. So that means I'll have a negative. The only thing that will change with my numbers is that they will both be negative, but the 18 and the 15 is going to stay, because otherwise they're like identical, aren't they? They're just in the exact opposite location across the x-axis. So -15, -18 will mean that when I flip and fold the x-axis, They match up with each other. Okay? What if they give you two quadrants, two ordered pairs that are in different quadrants, and it asks you to identify the axis? Is this a reflection? I know they're reflections because they're both ones in the x-axis. They're both threes in the y-coordinate. And so I know they are reflections, but I need to know, did they flip on the x-axis or did they flip on the y-axis? So let's draw and figure it out. -1, +3 will be negative positive, so that will put me in quadrant 3. And then positive will put me in quadrant 1. So in order to go from quadrant 3 to quadrant 1, I would have to have crossed the y-axis. Remember, this is the y-axis. This is the x-axis. So those two ordered pairs are a reflection across the y-axis. That's how they were reflected, and that's the mirror. The line of symmetry is the y-axis. Let's do another one. If we have a +4, that puts us here, 4, 4, and then a positive negative would put us right here, 4, -4. So with these two ordered pairs, they are identical. They are reflections, right? Because they're both 4 and 4 and 4 and 4. What axis do they need to flip over in order to touch, in order to reach each other? It is this one right here, right? They went over that x-axis. So those are some examples of how to find the quadrants, how to find the axis that they went over. Okay, so now let's do a little deeper thinking. Point D is a reflection of point A across which axis? Well, it's across the y-axis. How do you know that? Well, in order for those two to touch, you would need to fold on that line right there. And that line is the y-axis. Okay? What about which point is a reflection of point B? Oh, let's clear this up. We're starting at point B across the x-axis and then the y-axis. Can we reflect twice? Oh, this will be cool. Okay, so we're at quadrant 4, and it says which point is the reflection of point B across the x-axis. So we need to fold the x-axis. So now when we fold it, we'll be in the first quadrant. But then it says, and then the y-axis. So now we need to fold the y-axis. And where is that going to put us at? That's going to put us up here in quadrant 2. Cool. So we first went across the, I just tried to draw on my screen. We first went across the x-axis, and that put us at A, right? And then we went across the y-axis, which put us at D. So we're at point D. That's cool. And here's another cool thing. The next question says, look at the differences between the coordinates. Point B is 5, -4. Point D is -5, +4. It's like the exact opposite, right? When we go like diagonally, we have opposite signs. Instead of negative, positive, down here is positive, negative. That's cool. I wonder if that's true with the other direction. I wonder if we went this direction. So cool. We have a positive, positive, and down here we have a negative, negative. That's cool. So if we flip across the x and then the y, we're going to end up with the exact opposite numbers. Kind of cool. All right, so now I'm wondering, did you figure out any other rules? Did you figure out that if the x coordinate stays the same, it's reflected across the x-axis? Let's see if that's true. Let's go 3, 4, 3, -4. The 3 stayed the same. With both of them, I went to the right 3. But one I took the elevator up, one I took the elevator down, and that's true. It is reflected across the x-axis. So if the 3's are the same, they're reflected across the x-axis. Let's try that with y's now. What if we kept y's the same? What if we went -3, 2, 3, 1, 2, 3, 4, and +3, +4. So this time our 4 stayed the same. They both took the elevator up to 4, but one went left 3, one went right 3. They're reflections, aren't they? And it's true. They're reflections across the y-axis. So here's a quick thing you can remember. Again, if the y coordinate stays the same, they're reflected on the y-axis. If the x coordinates stayed the same, they're reflected across the x-axis. That's a quick way. If that doesn't stick with you, then just make your own little chart and do it yourself. All right, now we're going to see how well you do. What are the coordinates of the point -2, -3 if it is reflected first across the x-axis and then across the y-axis? Go. Draw it, figure it out. All right, let's see what you did. You could just draw a fancy coordinate grid like this. Go -2, -3. And then let's reflect it across the x-axis and then across the y-axis. So I'm going to keep the 2 and the 3. And the only thing that's going to change is I need the positive and negative signs for quadrant 1, which is positive, positive. So it's going to be across. It's going to be, the ordered pair will be 2, 3, positive, positive. Okay? Because we reflected x and y, we got the exact opposite of y. The grocery store is located at a point on the coordinate plane, so there's my coordinate plane, with the same y coordinates as a bank, but with opposite x coordinates. The grocery store and bank are reflections of each other across which axis? Ooh, we really got to think on this one, huh? Okay, so maybe I'll go like this. Here's the bank, here's the grocery store. So what do we know about both of these? Well, it said they have the same y coordinates. Okay, so it really doesn't matter what we put here. Let's say 5 and 5, okay? But with opposite x coordinates. So one will be positive, one will be negative. Let's choose 3. So the grocery store and bank are reflections on each other across which axis? So if we go -3, 5, and 3, 5, they went across the y-axis. So I drew it so I could see it, but if you remember the rule, if the y coordinates stay the same, then it's across the y-axis. All right, friends, give this a practice. Use your little paper. That really, really, really helps me. And I'll see you later.